In this session, we're still looking at complex roots, and we're going to work an example. Define the sixth roots of a complex number, z equal -64. To rephrase this problem would be to write it in the form of an equation. You can think of this same question posed like this: solve x to the 6 equal -64, and we're trying to find all 6 answers that will work. To proceed, we want to first write the number in polar form. The modulus is the square root of -64 square plus 0 square, as if this number is -64 plus 0i. And when you simplify that, you'll see that the modulus is simply 64. If theta is in the argument of z, then you know the tangent of theta is the imaginary part divided by the real part, and here we'd see theta is pi radians. Our number then, z, is written as 64 times the cosine of pi plus I times the sine of pi. The next step would be to apply the formula. Here n is equal to 6. We're looking for the 6th root, and we have w sub k is equal to 64 to the 1 over 6 power times the cosine of pi over 6 plus 2k pi over 6 plus I times the sine of pi over 6 plus 2k pi over 6. And here k goes from 0 all the way up to 5. And now it's just a matter of simplifying each of those expressions. W sub 0 is going to be 64 to the 1 over 6 times cosine of pi over 6 plus I times the sine of pi over 6. Let's make a note. 64 to the 1 over 6. We're looking for the 6th root of 64, and that's 2. So the modulus of each of those roots is 2. And the first argument starts at pi over 6. Let's make a little side note here. The modulus of each root is r to the 1 over n power. The argument of the first root is theta divided by n. You repeatedly add 2 pi over n to get the next argument of each successive root. The first one is 2 times the cosine of pi over 6 plus I times the sine of pi over 6. Second root, w sub 1, is equal to 2 times the cosine of pi over 6 plus 2 pi over 6 plus I times the sine of pi over 6 plus 2 pi over 6. And that can simplify what's pi over 6 plus 2 pi over 6. That adds together to give 3 pi over 6, and 3 pi over 6 is pi halves. So w sub 1 is 2 times the cosine of pi halves plus I times the sine of pi halves. The next root would be w sub 2, and that's 2 times the cosine of pi over 2, or pi over 6, I mean. So we could take pi over 2 and add another 2 pi over n, or we can just go back to the formula, and now k is incremented up to 2. So we have pi over 6 plus 4 pi over 6 plus I times the sine of pi over 6 plus 4 pi over 6. And that can simplify. W sub 2 is 2 times the cosine pi over 6 and 4 pi over 6 add together to give 5 pi over 6 plus I times the sine of 5 pi over 6. The fourth root would be w sub 3. This is 2 times the cosine of k now increments to 3. So 2 times 3 is 6 pi over 6. So pi over 6 plus 6 pi over 6, that would add together to give 7 pi over 6 plus I times the sine of 7 pi over 6. The fifth root, w sub 4, 2 times, now k is incremented up to 4, 2k pi would be 2 times 4 times pi, or 8 pi over 6. So we have pi over 6 plus 8 pi over 6. That will add together to give 9 pi over 6. And 9 pi over 6 can reduce to 3 pi over 2. And the last root, w sub 5, 2 times, now k is incremented to 5, so 2k pi is 2 times 5 times pi, or 10 pi. So we have pi over 6 plus 10 pi over 6. That will add together to give you 11 pi over 6. So cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. The geometry of this, all these roots will lie on a circle. That first root, pi over 6, well, that corresponds to 30 degrees. To get the next root, we want to add 2 pi over n, which is 6. So we're adding pi over 3, which is 60 degrees. Here's the coordinate system. A circle with radius 2. And the reason why we have that circle with radius 2 is the modulus of each of these complex numbers is equal to 2. If we sketch out a circle with radius 2, the goal, figure out how to divide this circle into 6 equal pieces. The points that are on the circle itself, that's divided into 6 equal pieces, will be coordinates of these roots. That first root, 2 times the cosine of pi over 6 plus I times the sine of pi over 6. The location of this point is W sub 0, and this is 30 degrees here. To get the next root, add 60 degrees. 30 degrees plus 60 degrees. The location up here is W sub 1, and if we look at W sub 1, we have 2 times the cosine of pi halves plus I times the sine of pi halves. Cosine of pi halves is 0. Sine of pi halves is 1. Coordinates of W sub 1 is 2i. Now we're going to add another 60 degrees. Gives us the location of this next root. W sub 2, remember, was 2 times the cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. Well, the cosine of 5 pi over 6 is negative square root of 3 over 2, and the sine of 5 pi over 6 is positive 1/2. Then adding another 60 degrees takes you down in the third quadrant. There's the location of W sub 3. We're at 7 pi over 6. And the cosine of 7 pi over 6 is negative square root of 3 over 2, and the sine of 7 pi over 6 is negative 1/2. 2 times negative square root of 3 over 2 minus 1/2 I would be the location of this fourth root. Now adding another 60 degrees takes you down here, W sub 4. The argument was that 9 pi over 6, and 9 pi over 6 reduced to 3 pi halves, and cosine of 3 pi halves is 0. Sine of 3 pi halves is negative 1. This root is negative 2i. And finally, the last root, adding another 60 degrees, W sub 5, 11 pi over 6. Cosine of 11 pi over 6 is square root of 3 over 2. Sine of 11 pi over 6 is negative 1/2.